This is the fourth problem from Leetcode Weekly Contest 369 called maximum points after collecting coins from all nodes. The problem simply says that we are given a tree. The tree has certain nodes and each node has a value associated with it, which is denoted by the array coins. And we have to collect these values from all the nodes. But for doing this, we have two choices. While at a node, we can either collect coins value at I minus k, where k being a constant, or we can collect coins value at I by 2. Choosing this condition will also reduce the value of all nodes in the subtree of that node by half. By applying either of these two operations, we want to see what is the maximum points we can collect from the complete tree. Let's see how we can solve this problem. So let's say this is our tree. This has every node in this tree has some value associated with it. And we simply have two choices. Either we can pick up coins value at I minus k, where k is a constant, or we can pick up coins value at I by 2. So the first obvious thought is we can iterate over all the possible permutations we can form choosing one of these two choices. Let's say while at this node, I choose to go with the first condition first. And doing this, I can collect a value of coins value at I minus k from this node, right? And then I can move to the other nodes in our DFS, let's say, and see by following both the conditions, what is the maximum sum I can get from this subtree and from this subtree, and then add up for this node, right? I can do this just a recursive DFS, and I can see what are the possible values. But while choosing condition 2, we will have to also half the values of all the nodes in the subtree of that node. So if I choose operation 2 for this node, I will have to half all the values in this subtree as well as in this subtree. All right, so even so, let's say this also had this as parent, right? So for this node, the value can reduce up to by 4, because let's say I choose second operation for this as well, so its value will be v by 4. So we will have to keep a track while doing a DFS. Let's say a variable t which denotes the number of times I have chosen the second operation in the ancestors of this node. So while choosing an operation, we will have to consider this variable t and first reduce the value of this node by t. Means we have to reduce it. It will become v by 2 to the power t. Okay, so we can perform this operation and find the solution using a DFS recursive solution. But the time complexity will be really high, because there are n nodes, and for every node we have two choices. So it would be kind of an exponential solution, but n is very large, kind of 10 to the power 5. So it is not possible to solve with this time complexity. So an obvious approach which comes to our mind here is we can apply dynamic programming here. So let's see what are the things that are repeating itself. For example, I came to this node. If I see, I'll have, let's say, n denotes the number of this node, n is the number of this node, and I will also have a value t which denotes the number of times I have half the value in its ancestor nodes, right? So I'll have only these two variables that will matter to me while I'm at this node. So I can consider them as the states of my DP, n and t, and I can form a solution with that. But n is 10 to the power 5, n is 1e5, and t, if we see, it could be n. If I have my trees over formed like a straight line, it could be up to n as well. So the time complexity in that case would become 1e10, which is quite large. But if we observe one thing, it is given that the value of the node do not exceed 10 to the power 4. Okay, so if I see what is, if I keep dividing this value by 2, at a time it will become 0. If I see what would be that time, So it would be approx 16-17 operations, after which it would start becoming 0. So it doesn't matter to me after those operations to keep count of this times value, right? So for me, I can keep a track of up to 16 values. And for all the above values, the answer will be same as the answer which was for the 16th time value. Okay, so this way I can optimize it. If I show you the solution, so this is the DFS I'm performing. I'm keeping the current node number and the times as my states in DP, and I'm taking minimum of 16 comma times as I told you. And if I have it, I return the answer. And I consider both the choices, that is I reduce it by k or I make it half, and this way I'm able to obtain the answer. So this way time complexity becomes n into 16, which is like 16 into 10 to the power 5, which passes.